the length of the videos that you guys have been getting in classes. Now we do want to end it with
Hey guys, today we're going to talk about a new topic, which is about quadratic expressions. Quadratic expressions are expressions in the form of ax squared plus bx plus c. Now these are some examples of quadratic expressions. I'm sure you've seen them before. Y equals 2x squared minus 8x plus 11, or y equals negative 4x squared plus 12x minus 9. But let's start by looking at the most basic type of quadratic expression, and that's something like this: y equals x squared. And if we try and graph y equals x squared, we end up with a graph that looks like this, and we call this curly shape a parabola. And a parabola can either open upwards or downwards, or to the left or to the right, but just understanding how a parabola works is important. So understanding how a parabola graphs, we know that at 0, at x equals 0, y is equal to 0 as well. But as x is increased, y increases exponentially. So at x equals 1, y still equals 1, because x squared is still equal to y. But at x equals 2, we end up with the point 2 comma 4, because y is the square of x, which is 2 squared. When x equals 3, 3 squared equals 9, so as you can see, the graph grows exponentially larger for y as x increases. On the negative side, because we are squaring the number, you can see that the graph never ever goes negative. As x decreases, y simply increases symmetrically with the other side. Okay guys, so now let's take a look at the graphs of some parabolas and understand a little bit more about how parabolas work. So in this case we have two types of parabolas. We have y equals x squared minus 4 and y equals negative x squared plus 4. In the future you'll have to learn how to graph these parabolas, but for now let's just understand some of the terminology around parabolas. So the graph of x squared minus 4 basically looks like this. It's a smiley face I like to think of. And the first point you want to think about is the vertex. The vertex is the ending point, or sort of the maximum or minimum point of the graph. In this case, the vertex of this parabola is 0, negative 4. The next 2 points are the roots. The roots are negative 2 comma 0 and 2 comma 0, and the roots are basically defined as the x-intercepts. So for our first two definitions, we have root is x-intercept, and vertex is basically the maximum or minimum point of the graph. If we come over here, y equals negative x squared plus 4, it's a similar type of graph, but instead of a happy face, now we have a sad face. So our vertex here is 0, 4. It's the maximum point of the graph. And our roots are still the same, negative 2 comma 0 and 2 comma 0. Moving on, we have what's called the axis of symmetry. And the axis of symmetry, the definition, is the equation of the line that cuts the parabola in half. So it's typically in the form x equals something. In this case, the axis of symmetry, you can see this red line, cuts the parabola in half at x equals 0. So the axis of symmetry here is x equals 0. Over on this side, we have the same axis of symmetry because it's the same line that cuts the graph in half, x equals 0. And finally, related to the vertex, we have a maximum or minimum. So that means the maximum or minimum value for y. Now for a happy face parabola, there is no maximum. There is no maximum because the parabola goes on forever. Right? But there is what we call a minimum. This is as low as the parabola goes. In this case, the minimum is negative 4. For a sad face parabola, for a parabola opening down, what we have is a maximum because this is as high as the parabola goes. So in this case, the maximum is 4, but there is no minimum because the minimum goes on forever. Okay guys, so now what we want to do is we want to take a look at quadratic equation forms. And that's going to help us be able to graph quadratic equations and also understand a little bit about how to find the vertex and the roots of different quadratic equations. So let's start with an example. Right now we have an example, y equals 2x squared plus 4x minus 16. And I've already drawn the graph for this for you. And right here we have a vertex of -1, -18. We also have the roots that are 2, 0, and -4, 0. Now let's break down the different types of equation forms of a quadratic equation. Standard form is the form that you guys are already familiar with, which is y equals ax squared plus bx plus c. Now, this is again the equation in standard form, and that's what you're used to seeing, that you're used to factorizing and finding the roots of. Standard form tells us basically only one thing when it comes to the graph, and it tells us if the a is positive, we end up with a smiley face type of graph. The graph opens upward. And that also tells us that we have a minimum, because the graph opens upward, this goes up forever, but we do have a minimum for the graph. If a is negative, we have a sad face, right, because we're negative. So that means we have a maximum. The graph only goes as high as this point, but it goes down forever. So standard form is not really very useful to us in helping us graph the equation of a parabola. These two new forms might be new to you, so we'll explain them to you. Vertex form is in the form y equals a times x minus h squared plus k. So this equation is the same as this equation, but just placed into vertex form. So this equation in vertex form becomes y equals 2 times x plus 1 squared minus 18. Vertex form tells us a little bit more, because it tells us where the vertex of the parabola is. In vertex form, the vertex of the parabola is simply h, k. So in this case, h is -1. Note the negative here, so we have to split the sign on the -1. The vertex in this case, the vertex is -1, comma, -18. And as you can see here, that's exactly where we have our vertex. So the vertex form tells us exactly where the vertex is, which is really useful to help us graph the parabola. It does the same thing as the standard form, actually. It also tells us the maximum and minimum. So if this a, right, this same a, if he is positive or negative, we also know that if the smiley face or sad face parabola should be graphed. Now the last one is the factorized form, which you also might know a little bit about, because you've factored many quadratic equations before. And the factorized form is simply y equals a times x minus alpha times x minus beta. So this equation factorized becomes 2 times x plus 4 times x minus 2. And the factorized form is really important for us because it tells us where the roots are, where the x-intercepts are. So the x-intercepts are at alpha and beta. In this case, when x is -4, and when x is equal to 2. Right? Exactly how we've done it in the past when we factorize quadratic equations. Okay guys, so let's take a look at this example. We have an equation here, y equals -x minus 2 squared plus 4. And what we want to do is find a number of things related to this equation. So the first thing they're asking us for is to find the vertex of this parabola. Now as you can see, this equation is already in vertex form, x minus h squared plus k form. So the vertex is h comma k, and in this case h, remember, flip the sign, so h equals 2 and k equals 4. So that means our vertex is 2, 4. Now it says state the maximum minimum value of y. Now in order to know whether the graph has a maximum or minimum value, we have to understand the shape of our parabola. And remember, the shape comes from the a, right? In this case, a is equal to -1. We have a negative in front. If a is negative, that means the shape of our parabola is a sad face. Negative, we're sad. So, in this case, we have a maximum value, because the parabola goes down forever, but it only gets to the top of the vertex. And as you've seen here, we already know what the vertex is, so the maximum value is 4. Last thing we want to find is the axis of symmetry. And if you recall, the axis of symmetry is the equation of the line that cuts the parabola in half, and it always comes in the form of x equals. Also note that the axis of symmetry runs through the vertex every time. So an easy way to find the axis of symmetry is to look at the vertex, and look particularly at the x-coordinate of the vertex. So if the vertex is 2, 4, then we quickly know that the axis of symmetry is x equals 2. That's the equation of this line. All right, last thing we got to do is sketch the graph. Now, if we're sketching the graph, all I need to do is find the vertex, which is 2, 4, and understanding the shape of the parabola, opens downwards, or sad face, I can quickly sketch my graph looking like this. Now, if we wanted to find the roots of this graph, what we would want to do is we want to convert our equation into standard form. So convert it into standard form first, and then once we are in standard form, we can factorize. So let's convert this guy into standard form. We would have y equals, multiplying this out, FOILing it out, negative x squared minus 4x plus 4 plus 4. Let's distribute out this negative. Negative x squared plus 4x minus 4 plus 4. These two guys cancel out. We end up with negative x squared plus 4x. Now when we factorize it, here we can factor. If I factorize this equation, what I'd end up with is y equals, taking out a negative x, x squared, x minus 4. So our roots in this case are x equals 0 and x equals 4, which looks very much like our graph, right? Our roots here are 0, 0, and 4, 0. And there we have it. Okay, guys, so for your practice problem tonight, what I'd like you to do is take a look at this equation, y equals 2x minus 3 squared plus 1, and do the same thing that we did in the example. Find the vertex, state the maximum and minimum of y, find the axis of symmetry, and sketch the graph.